Good afternoon, everybody. I'm Steve Dahl, I'm the president of D2D Technologies. Some of you may be looking at the title here and wondering if you're in the right place. Yes, you are. I've had a little change. As I was preparing this presentation, realized that broadcaster apps are really part of a more general key to success of ATSC 3, which is data applications. For me, data applications consist of two major categories: broadcaster applications and data casting. So what is a broadcaster application? Basically, a broadcaster application consists of a client-side web application with resources such as HTML5, CSS, JavaScript, images, and multimedia delivered in the ATSC3 stream. Then at each ATSC3 compliant receiver, there's a server-side application which can render these resources. There's also a WebSocket protocol used in the broadcast application to communicate with the receiver. This allows you to get user settings, receive event notifications, and request actions such as video scaling. Also is what allows you to use a remote to move a cursor around the screen. Kind of gives you that interactive feeling of ATSC3. But one thing about these receiver side servers is they're very simple. About all they can really do is render the pages. But if you do have a broadband connection, the broadcast application can also receive, connect to servers in the cloud, and you get a lot more richer, complex applications such as processing payments, user authentication. So you can do a lot of interesting things if you have an additional broadband connection. Data casting, something which leverages broadcasting's one-to-many architecture to push data to remote devices. And this has been around a long time, since the early days of ATSC1. But one of the issues with ATSC1, the devices you're casting to have to be stationary. With ATSC3, you can now send to mobile devices. So you can have a device in a car going 70 miles an hour down the highway, you can cast to that. Or in some of these new exciting applications, you may actually cast to the car itself. But one thing about data casting, traditionally it requires custom receivers which know how to process the data. If you think about it, the data you're sending is proprietary typically. There's no standard, so you have to have some sort of receiver at the other side who knows how to extract that information and what to do with it. This kind of brings me to another interesting concept with ATSC3, and that's the companion devices protocol. This allows you to have a hybrid application using both broadcaster apps and data casting. It's basically a protocol for the broadcaster app which allows you to communicate with other devices such as computers, tablets, and mobile phones. And in some ways this can help solve some of the issues involved with expensive custom receivers needed for many data casting applications. Let me kind of give you an example how this could potentially work. So this here is a overview of the PBS warn system. It's a project we developed in partnership with PBS. It's basically a backup system for the wireless emergency alert system. And what this is doing here is FEMA will generate the alert messages. They send it over the internet to the mobile carriers, then it's broadcast out to all the cell phones which are needed for that particular market. But what happens if the internet goes down? You may have a hurricane, an earthquake, active terrorism. How do we get those alert messages to the mobile phones? The answer is the PBS warn system. So the alert messages will also go to the PBS satellite uplink. From that point, they'll go by satellite to all the member stations across the country. And then at each PBS station, there's a D2 warn system, which is what we developed with PBS. And it will receive that satellite feed, take out the wireless alert messages, and then inject them into the over-the-air local over-the-air stream. But what this also requires is a custom receiver in all these different locations for every mobile carrier, which knows how to receive that alert message and pass it on to the wireless carrier's computer system. But what if we had, for ATS3, a similar system, but instead of having a custom receiver in all these different locations receiving the over-the-air stream, everything would basically be the same, except in the over-the-air stream, in addition to the wireless alerts, we're also sending a broadcast app. And when that gets to just any commercial receiver which does companion protocol, the broadcast app knows how to extract that information, and it can send it to the wireless carrier's computer system without the need of having custom hardware delivered to all these locations. Now we've talked a little bit about what broadcaster applications and data casting is, let's go over a few examples. At D2D, we're in the process of developing a broadcast app, and one of the features is Enhanced Electronic Service Guide. Now in ATSC 1, if you're all familiar, the guide is always text only. But with ATSC 3, you can now start adding graphical content, such as show cards or pictures of actors. As you can see on the display here is a screenshot, and you can see actually the show card. So now when you're looking at what's coming up, you don't have to read it. You can actually just tell by the image of what's going to be coming up soon. You can also add additional content such as metadata, actor bios, links to IDMB entries. You can also do previews and links for station VOD content. One idea I'm kind of thinking of, sure a lot of you may be familiar with PBS Passport. It allows you to stream PBS's award-winning content over the internet. Well, what if you had an application that you're watching your typical linear content of PBS, but once, say, Frontline's over, you bring up your app, you go to Passport, and now you can start streaming last night's Nova program right to your device. Another thing that the ATSC 3 Electronic Service Guide allows for is branded and consistent look and feel across different receivers. Now each receiver is going to have their own service guide, but that's going to be combining together all the different channels that it's picking up. But it'll probably be a very general guide, and it's going to be different from manufacturer to manufacturer. With the broadcast app service guide, a broadcaster can basically brand it specifically for their station, and it'll keep a consistent feel across all different receivers. Another feature of broadcast app is advanced emergency alerts, or as we like to call them, advanced emergency information. Now one thing I want to try and help clear up here, it seems there has been a lot of confusion with a lot of people thinking that these advanced emergency alerts will replace the traditional EAS system, and that is not the case. You'll still have your national alerts, you'll still have your weekly, monthly tests, but these advanced emergency alerts allows you to, in some cases, enhance traditional EAS, and in other cases come up with completely new applications. One way that can enhance traditional EAS is providing additional metadata. So we're based out of Florida, so every summer the hurricanes start rolling in, and you could have the situation as the hurricane gets closer, there's a traditional EAS alert which says that we've now entered into a hurricane watch. But as it continues to get closer, things are very fluid, things are happening, there's hurricane evacuations, then that causes traffic jams, so you could have traffic updates so you know which route to take. There's also bridge closings. So in Jacksonville, where we're located, out at the beaches, the only way off the beaches is by a bridge. But as the hurricane gets closer and the winds pick up, the bridges close. So it'd be very important to get alert that, hey, the bridges are closing in 30 minutes, you better get off the island. But what's nice is with these alerts is they can be filtered by county. So if you live out at the beach, it's very important that you can get off the beach. But if you live 50 miles away on the other side of town, away from the bridges, you're not really concerned about these alerts, so you can opt out of these. And some of the new features that you can get with these advanced emergency alerts is PSAs. So there's a lot of very important information, but really hasn't, in the past, risen to the level that you're getting an actual EAS alert, but you still want to get this information out. Some of that could be like major traffic disruption. In California, to have what's called a SIG alert, if for some unexpected reason a lane closure is going to extend for over 30 minutes, these alerts go out. So you could have something similar with one of these alerts where there's a major traffic bender, multiple cars involved, blocking traffic for quite a while, and one of these alerts can go out. And what I think would be very interesting to broadcasters is this can also provide some opportunities for revenue generation. So this alert not only can explain that, hey, you know, this highway is backed up, you want to take an alternate route, you can also have a little banner at the bottom saying, you know, sponsored by, you know, insert your favorite local personal injury lawyer. You know how they want to advertise on everything. So that's a way to kind of actually start using this to generate some revenue. And actually another kind of cool, interesting thing, make it interactive. You can see on the screen capture there, that's actually a screen capture of us doing a weekly alert. And it's actually using actual standard NVISA, which is a group that we're a member of, which is trying to give a common look and feel to these alerts. And you'll see there's a little triangular icon there in the corner. And what you can do to make this interactive, you can actually have just the icon on the screen. So say there is a 4-hour tornado warning in your area. You can have that little icon down there in the corner with the little tornado symbol. So it's kind of there, it's in the back of your mind. You may want to know it's around, but it's not really interrupting your viewer experience. But at some point you want some up-to-date information, you just click on the icon, it brings up the crawl again, or a slate to kind of give you the latest, and once you're up to date, just click to close it again, it just goes back in the corner again, mostly out of your view. Now I also want to talk a little about a couple of data casting applications. WUNC is a PBS member station based in North Carolina. They're involved in a couple very interesting pilot programs. The first is a public safety data casting paging. And the issue here is there's still some fire and EMS emergency call systems which still use outdated analog paging systems which are very slow. So for example, say you have a 4-alarm fire. The way this would work in analog, you first get a 3-second tone which kind of identifies what station this is going to. Then you may have a 15-20 second actual audio clip of what the actual event is and where they need to go. Now since it's a 4-alarm fire, you have to send this to 4 stations, so by the time it gets to the 4th station, it may be 2 minutes have gone by. And when you're talking a major fire like this, eliminating those 2 minutes could literally mean the difference between life and death for someone. And the way the datacast paging works is the device itself would be replaced by a new component which would have an ATSC receiver in it, and then also have the ability to do text to audio. So in that case, you don't have to send an actual audio clip anymore, you just send the text with a filter code. So now this 2-minute process is now milliseconds, basically making it instantaneous. Now I was kind of reading about this and thinking about some of the capabilities of ATSC 3. I was thinking about potential future enhancements. You can maybe use the data casting to send additional content such as building floor plans, or maybe live updates from the scene, so when the fire engine arrives, they know exactly what's going on, kind of speed up the process. Another interesting pilot program they're working on is addressing remote learning needs. There's still significant gaps around the country where people don't have good broadband access. And this became very obvious during the pandemic when all the schools shut down and different school districts were trying to get out the educational materials to the different students, and this became very challenging in areas where they didn't have good broadband access. So what this does, it basically utilizes ATSC's one-to-many architecture to push lesson plans, study materials, quizzes, etc. out to the students who don't have broadband services. Now one thing about this though, it does require a custom gateway receiver at each student's home which can receive the over-the-air broadcast, extract the educational material, and pass it on to the student's device. So it kind of got me thinking, is there ways you can maybe, as I talked about earlier, using a broadcast app along with the companion protocol, basically send the broadcast app out along with the educational material, and the broadcast app at the receiver will extract the information, then use the companion protocol to send it over to the student's device, eliminating the need to send a custom receiver out to every student. So in conclusion, today we've been talking about data applications, how they're the key to the success of ATSC 3 by keeping viewers engaged and generating new revenue sources. There's 2 main categories, which are broadcast applications and data casting. And one thing which really excites me is this is just the tip of the iceberg. There's a lot of really creative people in this industry, and once we start getting out the message of all the different capabilities of the new standard and what it can do, people are going to come up with some really amazing, game-changing ideas. In fact, there may even be somebody here in the audience today who has a really great idea but has no idea how to get started. So if that's you, come by and see us. We have a great team. We love working on custom applications and doing cool things with our partners. So come by. We're just right over there, W9014. You can come talk to us.